Time to do some science experiments. Got a little magnetic stir bar. We're going to pop it into our flask and get her rolling. Try to center it just a little bit. There we go. Now into the flask, I'm going to put some Evian water today into our flask. I'm not selling this. This is just part of the experiment. Here we go. In goes, let's see how many things the Evian water is going to take to get this bottle filled, or excuse me, this flask filled. Probably 2. There's 1. There goes the next one. Science is the best, Arjun. Tell me about it. There's our second one. That fills nicely. So we got 2 bottles of Evian water in there. Absolutely, Arjun. Okay, let's see what the pH of our Evian water is. There's the different pH values and the different colors. What's up, moms? What's up? Life's good? All right, I got some Evian water in there. There's my different colors you're going to see with the different pH values. Let's see what pH Evian water is. In goes the universal indicator. You'll notice it's green in color. Let's see what happens when it goes into the Evian. Looks like the Evian's got like a pH of around 7. And that makes sense to me. Well, why does that make sense to me? Well, because that's what it says on the bottle. Here, check it out. Hold on a second. Where's the bottle? Right here. Right down there. See it? pH 7.4. Excuse me, 7.2. Yeah, so Evian water is pretty much neutral. That's from the additives that are in there. If it was purified water, it would probably be pH 6 from, the carbon dioxide that's going to be dissolved into any sample of water that's exposed to the atmosphere. And indeed, the Evian water is certainly exposed to the atmosphere. So it's definitely green. Then if you've been around, you know what we're going to do is start to add a little bit of, let's add some acid first. I'm going to add a drop of acid. Let's add another drop of acid. 3 drops it was, 3 more. Oh yeah, it's like a little traffic light action. There's 5 drops. There's a couple more. Looks like there's going to be some additives in there that are kind of buffering the water. And what I mean by buffer, a buffer is just a solution that resists changes in pH. So I'm adding some pretty strong acid here, and the pH is not changing a whole lot. Trying to get our pH down to, maybe 3, 4. Looks like we're down to about 5 right now. Yeah? Here, I'll move this over so we can see it just a little bit better. There we go. Thanks there, Barrow. I appreciate that. Oh, live good. Liked it. Life is good. Liked it when I poured some liquid nitrogen into a tube. That was cool, man. I don't have any liquid nitrogen at home. I'm adding acid right now. And as I add acid to the flask, of course. Thanks, sir. Life is good. I appreciate the comment. We are down to pH 3. Let's try heading it in the other direction. So I'm going to now start adding sodium hydroxide. Barrow, I've never tried putting cesium in water. I've done rubidium as far down the chart, far down the column, I should say, the group of the alkali metals that I've gone. So I have put rubidium in water. Both times it broke the beaker of water. And one time it burned a hole in the desk after the beaker broke. I'm adding a little bit of come on, man. That's just gorgeousness. This is working really well. I'm using Evian. Look at that gorgeous rainbow. Come on, man. That's just pretty. Life is Good wants me to make it all the way as basic as I can get. We're going to do that. I'm going to keep adding base. Drops of base. Boy, that Evian water is really looking pretty. We got a little aqua down at the bottom. Come on, man. Thank you there, Life is Good. I really got the colors going well. I should use I think I should use Evian water more often. I'm going to keep adding some base here. A couple drops. Got a little aqua again. Beautiful sky blue color. Man, is that gorgeous. So Barrow's got some cesium and rubidium. That is cool stuff. What's your favorite element that you have, Barrow? Barrow's an elements collector. Just curious, like, of the elements that you've collected, which one are you kind of most interested in or maybe even most proud of? I'm going to keep adding some base here while Barrow answers us. Got to a nice blue color. We're at like a pH of 9 now. I'll keep adding some base up here at the top. Try to get her all the way to pH 10. I think we're there. I mean, that's as violet as I can get it right there. Iodine is beautiful. We kind of got the color of, iodine here a little bit. Thank you there, A Master. Welcome aboard. Glad to have you on board. We're just doing, what does it mean if you are the most acidic, asks Life is Good. On this chart, it just means your pH is 3. That means your concentration of protons is about, it's like, 0.001 molar, but that's still pretty high in terms of protons in solution. I'm adding acid right now. My favorite element, and everyone feel free to drop your favorite element in the chat. Mine happens to be hydrogen. It's the basis of all the periodic table. I do too, AE Master. Chemistry is just a lot of fun. And in my case, in my opinion, I should say, thanks, AE Master. I appreciate that. Appreciate the subscription. Yeah, I'm adding some hydrochloric acid to this solution here, and you can see the different pH values that you're looking at in the flask. Could I drink that water that basic? Sure. I mean, this essential water is like pH 9.5. And you can see it right here. Yeah, pH 9.5 or higher. So this, if I put some, here, let's just do it. I'll put some universal indicator into some essential water, which they, put some additives in there to make it alkaline. It's a hoax, though, folks. Don't be thinking that this alkaline water is like going to do anything for you. Here, I'll show you why. Let's add a little bit of Fiji. I don't have a sample of Fiji with me, Barrow. I apologize, but I do have some essential water, and we're going to add some essential water to this flask right here, and we're going to test its pH. And it goes. And then I'm going to do a little experiment real quick. All right. Looks pretty. I think it is getting, I think we're down to like pH, you're right, around pH 4 over here on this side. I'm going to add a little stir bar over here on the right-hand side. Remember, I added essential water here, which people say, there's a lot of claims about alkaline water. The one that irritates me the most is that it will alkalize your body. Mindy, I got some tap water. Please remember that tap water, has a wide variety of, I should say its composition is variable. So here's the universal indicator. I'm now going to add this to the essential water. And as expected, it's got like it's a beautiful violet color is what it is. And that makes sense to me because, they put additives in there to make the pH 9 or 10. So, yeah, you can drink fluid that is at pH 9 or 10. You just don't want a whole lot of alkaline material in there. It'd be bad for you. Base reacts with you and it tears you up. So let me show you why you're not going to alkalize your body by drinking this stuff. All I'm going to do is I'm going to just start exhaling into this flask. And by doing that, I'm just going to be blowing carbon dioxide into this flask. And carbon dioxide, that's, we produce that all the time in our cells. Okay, Jaden, thank you. Appreciate that. So here we go. I'm going to just start blowing into this flask over here. I can't blow too hard or everything will shoot out in the flash. We can see that, the pH is already changing, right? It's dropped from pH 10 down to maybe between 7 and 8. And that's just by me blowing gently into this. The carbon dioxide I'm naturally producing in my body is going to, it's going to neutralize the tiny, tiny, tiny bit of base of alkali they have in here. I'll go a little further. So you can see I've already neutralized it. And that didn't take very long. And you should also recognize that most of the carbon dioxide I was blowing into here was not going into the solution. A lot of it was, gurgling out. And so the point here is that, they sell this stuff as being able to alkalize your body. Thank you there. Was it Jaden? I should add dry ice. Life is good. Yeah, it was Jaden. So they sell this as something that can alkalize your body, but that's, come on, man. For people with kidney problems, drinking large amounts of alkaline water can be harmful because their kidneys can't regulate pHs effectively. Barrow, in my opinion, and you can read more about this, the amount of, dissolved material in here is minuscule. I mean, it's a very, very tiny amount. And so, the minerals, basically, that they dissolve in this stuff is small enough that I think your kidneys are going to be able to flush those pretty well without any issue. However, I could be wrong, and if you have any, sources from legitimate scientific studies, I'm always happy to change my mind and learn. Yeah, T-Boogie, I hate to tell you that, but... I like it. I drink this stuff because I like the taste. I like it better than, most other water. So that's why I buy it. But there's just a drop there of acid. And here's another drop. And here's another drop. So these drops, 8 of them, 8 drops of this acid is equal to the amount of acid that's present in your stomach. Just 8 drops of this stuff. Okay, same number of protons. And you can see I did 3 drops, and we already acidified this stuff, man. If the most acidic thing is in batteries, what's the most basic thing? So like life is good, the most acidic thing is actually not found in batteries unless you're aware of a battery that contains fluorantimonic acid. Fluorantimonic acid is highly acidic. Okay, here we go. ILT wants 10 drops. So here we go. 10 drops of acid over here on the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We are at a pH of 3. Way down there. And now we are going to try. We're going to try to neutralize the acid, and I'll do that by adding base. So here goes the base. I'm going to add, let's go like 3 drops of base. 1, 2, 3, let's go 4. Let's go 5. There's 5 drops. Let's see what kind of color changes we get. Come on, man, that's pretty. There's your yellow, Nobara. There you go. Hey, AV Rocks. AV Rocks from India. Welcome aboard. Yes, that's correct, Master. It is 20% by weight. Hydrochloric acid is what I'm using. It's absolutely what I'm using. Me too, AV Rocks. Me too. All right, let's add base to both of these. 1 drop over there on the right. Oh, that was cool. 2nd drop over there on the right. 1, 2, 3, 4 drops on the left. Excuse me. Oh, we got the rainbow. We got the rainbow on the left. Come on now. Jaden wants me to mix some stuff together. How you doing there, Julie? Hello, Isaiah. Hey, this is fun to do. We'll do it. We'll mix them together. So hold on a second. I'm going to add a couple drops of acid over here. I'm going to get this side acidic. All right. And then over here, I'm going to get this side basic. So we're going both sides. I can't do pink, Nobara. Cannot do pink. I don't have phenolphthalein with me. Okay. All right, let's see here. What I'm now going to do is, I've got these at the extreme ends of the pH region. So over here on the right, we're at pH 3, which is quite acidic. Over here on the left, I have pH 10, which is quite basic. And someone asked, let's mix them together. So Master mostly watches Now Red. Yeah, Now Red is awesome. Now Red is awesome. So let's see, I got to mix this stuff together. Hold on, I got to find a flask where I can pop these things into. We'll use this. We'll stick it right here in the middle. All right, and let me get some droppers so I can do this. There we go. 2 droppers. Pardon me. Thanks, AV. Appreciate that. Here we go now. So I'm going to take 1 squirt of the red, 2 squirts of the red, 3 squirts of the red, 4 squirts of the red. All right, let's do the same with the... That's what I'm doing right now, Fairy. 1 squirt of the violet, 2 squirts of the violet, and look at that. They neutralized each other, right? They turned a green color. Actually, it's gone to yellow now. So what happens, right, when you mix an acid and a base, so I mixed the red stuff with the purple stuff, something that's fairly strongly acidic with something that's fairly strongly basic, the acid got less acidic, it went toward neutral, and the basic got less basic, it went toward neutral. It's exactly what we observed. That's what happens, and you can balance it, right? If I want to lower that pH a little more, I'll add another squirt of acid. If I want to raise the pH a little more, I'm going to add some squirts of base. I'm going to see if I can't get it to a green color where there it is. Well, that's a little more pH 8, wouldn't you say? Let's see, I'll just swirl it for a bit. There we go. There's your green. The acid and the base have neutralized each other. So that's what happens when you mix these two. They're gonna be somewhere in the middle. That's what's going on. Thank you there, Fairy Girl. Drink it now, says Isaiah. See, I wouldn't want to do that, Isaiah, and here's the reason why. These indicator dyes, there's the universal indicator is actually composed of 4 different dyes. I'm going to add some acid over here on the left, by the way. And one of those dyes is a laxative. So if I drank it, the live might end in, 10, 15 minutes or so. All right, let's add a drop of base over here on the right. See what we get. Let's add another drop. Another drop. Pretty stuff. Woo, look at there. I got some violet that faded to blue and green. Looks like we're neutral over here on the right. I'm going to keep adding acid over here on the left. See if we can't get this to a pretty low pH. I'm alone here in my basement, Isaiah. My wife's at work. Thanks, Aliverse. Thanks, AV Rocks. No, I'm not adding baking soda. The base I am adding is 20% by weight sodium hydroxide. All right, I'm still adding acid to the left. Thank you there. I know it's not Mindy, it's Jaden. Every time I see the name, it's a little tough here. Keep adding. I'm going to try to get the rainbow effect, which is just so much fun when it happens. Okay, I'm going to turn this speed down just a bit. We're going to turn this speed down over here, too. And let's add 3 drops of base. 1, 2, 3. See what we get over there on the... There it is! There's your rainbow on the left. Come on, let's see if we get the rainbow going. Look at that gorgeousness. So yeah, what we're doing today on the live stream is what I normally do. This is the usual experiment that I do, in which I just add either acid or base to a flask that contains universal indicator. And universal indicator, thanks there, fairy girl. Universal indicator displays these colors at these different pH values. That ain't happening, buddy. So over here on the right, you see we've got a green color. That's neutral, pH 7. Over here on this side, it's yellow, which is going to be just slightly acidic. Just a little bit acidic. So let's see. I'm going to add a couple drops because I like it when you get a whole bunch of different colors at once. I'm going to add a bunch of drops of acid over here. Get the pH lowered. Add drops of acid over there on the right. Dump it in. There we go. No, it's still kind of orange. That's like pH 4 or 5. That's one more drop. There we go. We're going to get that down to pH 3. I'm going to turn this off completely. Let's turn the stir bar off completely. And then I'm just going to add, I don't know, 4 drops of base. 1, 2, 3, 4. And then let's add 2 drops over here. Let's just see what happens. Boop, boop. There we go. That'll work, AE Master. You can get quite a few colors if you use that. So the spinning colors over here are gorgeous. Really nice effect going on. It's mesmerizing. Yeah, it's very nice. What do we got going on over here? Not a whole lot over here. This is a little nicer. I'm gonna chase it just with a little bit of acid. See if we can't get some cool colors going here. A little bit of base. Just keep going and just see what happens. How fast would I have to stir the beaker to get CO2 in the air to dissolve and change the pH from neutral to 6? So, Geron, these bottles already have carbon dioxide dissolved in them. So because of that fact, here, I'll just show you, okay, Geron, we'll just show you this. I'm going to take some purified water. So let me get this flask off. It's already got the CO2 in, as much as is going in there. All right, let me get another flask here, and we'll do an experiment for Geron so he can see this, or they can see this. Sorry, I don't mean to assume. All right, pop this on here. And what you're going to see, Geron, is I'm going to add some distilled water, which is, you know, it's very purified. Highly purified water. I just opened it, and you can see it's distilled, and in it goes. And, you know, distilled water is very pure. It's just not exactly pure. And the reason why it's not exactly pure is because, you know, even though this stuff is bottled, there's carbon dioxide that's been dissolved. It's, you know, this stuff's exposed to the air, the distilled water. And any water that's exposed to the air is going to have carbon dioxide dissolved in it. And so, you know, most people are going to think that because it's pure water, it's going to be pH 7. Because, you know, perfectly pure water is going to be pH 7. But because this has some carbon dioxide dissolved in it, here we go. I'm going to add the indicator. Ooh, if I backlit in a dark room, the colors would show on the wall and ceiling. Block, we might try that. So here we go. I'm going to add the universal indicator, which you can see is green. And I'm going to add it to the purified distilled water. And it turns yellow. And yellow, let's look at the color, what that means. Yellow means pH 6, which is slightly acidic. So it's slightly acidic because there's going to be a little bit of carbon dioxide dissolved in there. Thank you there, J.A. Let's add another squirt here. Look at that. We got a little vortex going on. It's interesting how the material stays in the middle of the vortex, and that actually makes sense because, you know, just like the eye of a hurricane has low pressure, the eye, so to speak, of this vortex also has low pressure, and material moves from high pressure to low pressure. Yes, Isaiah, I am a science teacher. And since the middle of the vortex is low pressure, it's already where it wants to be, so to speak. And so that's why it tends to stay concentrated there in the middle. Thank you there, Jaden. I appreciate that. I tell you, I'd love to be your science teacher. How do I properly dispose of base acid? You just neutralize it. For college, Isaiah, you just neutralize it. There we go. And then it just turns into a salt and water. I'm adding base to the flask over there on the left. Thank you, ZYX. And now I'm going to add some some acid to the flask on the left. 4 drops. See if that's enough to neutralize it. Fairy Girl does look like it's spinning but not mixing, but it is, as you can see, there is some rotation there from the tiny, tiny little stir bar I put in. I love some chemistry too, ZYX. Sorry, Isaiah, I can't do that. Certainly not on a YouTube live stream. Look at the colors that are developing. Just absolutely beautiful. Let's add a little bit more acid here. 1, 2, 3, 4. Let's see what we get. Make bromine. SN, I've got some videos about bromine. You want to check it out. Your science teacher gave you a real diamond. I like turtles. That's cool, man. Sure. Thank you there, Oren. Thanks for the explanation. So how I was teach to titrate quickly to reduce the influence of CO in the air. Not necessarily there, Jaron. You know, if you titrate quickly, the reaction between carbon dioxide and sodium hydroxide is slow. And sometimes you're able to navigate that by titrating extremely quickly. But I don't have a whole lot of experience. You know, it's not like I do titrations every day. Oh, AV, I do get some of my own students in my lives every once in a while. Sorry, SN, not gonna happen. I'm in my basement. I don't have any of that in my basement. Hello there, Tier. I do not have any pure uranium. That's correct, AE Master. That is correct. I actually have a short form video and a long form video in which I do exactly that. So I burn a diamond in some liquid oxygen. So if you want to check out my videos, you can see some of those experiments. I want to get this a little lower because, yeah, look at that. You can see the pH gradient there. Do I have a favorite chemical reaction? Wow, what a great question. Thank you there, Tier. Everybody, yeah, I think so, AELU. I think what is my favorite chemical reaction? Man, that's a great question. Whichever one I'm doing at the time. How about, if you folks have a favorite chemical reaction, why don't you drop those in the chat? You can check it out. I'm adding base to the flask on the right now. Let's add some base to this flask over here. Some cool stuff. I do have a cube of tungsten. 1, 2, a little bit of acid to the oh, look at that. That was a sweet color change. The iodine clock reaction is indeed an interesting one. I don't have any of that in my basement. That's at my office. I actually can, Isaiah. Isaiah wants to know all the steps for why Coke and Mentos works. So here's the way it works, Isaiah. Mentos candies, as you probably know, have a lot of pits and pockets in them. And what's interesting about those pits and pockets is they have an extremely large surface area. And that combined with the high surface tension of water or, carbonated beverage means that when you drop a Mentos candy into a water-based beverage, those pits and pockets, the water doesn't sink all the way down into the crevices. We say the pits are unwettable. And what that means is is that the pits and pockets, there's air pockets in there because the water, here, imagine these are the pits and pockets, right? The water can't get all the way down in there because water has a high surface tension. And so let's say the water only gets down, say, this far. Well, that means this region here, right here, is an air pocket. And that's important. That's important because it is very difficult to form a bubble in water, okay? And so when, you have a carbonated beverage that you open, you have a lot of dissolved carbon dioxide in that beverage that wants to form bubbles and come out. But it doesn't because it's so stinking hard to make a bubble. Well, the deal with the Mentos is, like I was saying here, because each pit already has an air bubble in it, it sort of mitigates or passes this requirement to form a bubble because the Mentos candies, basically you throw Mentos candy into water or a carbonated beverage, you're throwing millions of ready-made bubbles into the beverage. And those ready-made bubbles provide escape routes for the carbon dioxide. So in it goes, you've got these bubbles, and then all the dissolved carbon dioxide just simply moves in, and the bubbles expand, and it happens over and over again, and then you got a mess. Out it comes. How does the acidity or alkalinity of liquid change the color? So the reason why that happens, we'll talk about it this way. So I'm going to talk about this at the level of molecules. We're just going to talk about one of the molecules that happens to be in this indicator system. There happens to be 4. We're just going to talk about one of them. Thanks, sir, Isaiah. And if you want to learn more, I have a long-form video that talks about it in detail. It's called The Science of the Coke and Mentos Experiment. I've actually published about 10 papers on the subject. So, yeah, if you have any questions, pop them in the comments of that long-form video on the science of Coke and Mentos. Anyway, how does the acidity change the color of the solutions that I'm messing with? Well, I'm just going to talk about one of the indicator dyes that are in there. There's 4. These are the 4 that are in there. So they're all 4 in there. And we're going to focus on this one, phenolphthalein. You see, phenolphthalein, it's an easy one to talk about. It's either colorless or it's pink. And the way it works is phenolphthalein is a ring-shaped molecule as long as there's lots of acid around. We're gonna pretend that this red circle is a proton, which is what acids donate. All right? Let me get a little bit of color change here so we can see some stuff happening while I'm jabbering on. So if there's a lot of acid around, the phenolphthalein molecule locks on to the protons that are given up by the acid, and when it does that, it takes on a ring shape. And when phenolphthalein has this molecular structure, it's colorless. So when there's a lot of acid around, phenolphthalein is going to be colorless, and it's going to provide no color to our system here. If there's base around, what the bases do is they grab onto the protons. They take them away. So when there's a lot of base around, that's at the high pH end up here, the phenolphthalein molecules lose the proton. And when they do that, they go from ring shape, doink, to open like this. So it's like this. Colorless, boop, and then it opens up. And with that change in structure from ringed to open comes a change in color. Colorless to pink. That's how you get a color change with phenolphthalein. All right, so when I start adding a whole crap ton of base here, it's going to steal all those protons from the phenolphthalein. And you can't see the phenolphthalein is turning pink, but basically what's happening is the indicator would be blue at the high pH without the phenolphthalein. But with the phenolphthalein, you get blue and pink, which gives you violet. So that's what's going on there. I have a, yes, I do, DN. I do reuse these indicator solutions. Well, if you're going to reuse them, what you want to do, of course, is seal them up from the atmosphere, which I do, and also make them low pH. Isaiah, check through my most recent short form videos, and you'll see one of my colleagues performing the elephant toothpaste reaction. I have quite a few. I have another short form video. It's got a couple million views, or maybe just over 1 million views, that talks about the gas that's produced in the elephant toothpaste reaction, which is oxygen, and then I do a little experiment with that. Samson, add some Gatorade. I apologize. I don't have any Gatorade. No Gatorade on hand. No Gatorade on hand. Sorry about that. All right, let's get some acid added over here. Yeah, this is a unbuffered system, so the colors are changing really fast. Ooh. Yeah, maybe, but not today, Isaiah, because I'm in my basement and I don't keep you know, the more caustic materials that are necessary to do elephant's toothpaste in my basement. So I'd have to be in my lab to do that. Oh, let's watch this one here. This one's got some nicer color changes. They persist a little while longer because this system is buffered. All right, here we go. We're gonna make this acidic here. 5 drops. Sorry there, Isaiah. We're gonna add a few more drops here. Pardon me. All right, we got a nice low pH system. And now let's add some base, baby. See what happens. Here we go. Let's see if we can catch the rainbow. I think we did. I think we caught the rainbow. How you doing there, Deadpool? We got a little flash of rainbow action, which I always love. Love it when we catch the rainbow. We're going to try again. I'm going to turn the speed down just a bit. Just a little bit more. Don't stop. Don't stop. Okay, that's going to be perfect. It does look like a tornado. Thank you there, Deadpool. The Skittles. All right, here we go. 1, 2, 3. Let's see if that gives it to us. I don't think it's gonna. Oh, look at there. I was wrong. I was wrong. We got the rainbow, baby. Come on now. Come on. We got some rainbow action going on. Look at that, y'all. Just beautiful. Base incoming. I'm going to make this acidic again. It works better if I start at the acidic end and then add base. A little bit more. There we go. One more drop. Thanks there, Deadpool. How many subscribers did I have when you joined on, Deadpool? I'm getting up there, man. I'm up above 600,000 now, which is kind of nice. I appreciate all the subscribers. I really do. You know, getting more subscribers definitely motivates us to keep doing this. It's true. But I also do it just because I love science. Look at this. Come on, man. Look at that. Come on, man. Oh, we're going to need a little more purple. Let's go 2 more drops, see if we can't catch the rainbow. Yeah, come on. That was gorgeous. It does look like the Northern Lights in a glass, Billy. It's just so pretty. Let's get some more acid in there. I remember seeing a 3-color clock reaction similar to iodine. I can't remember how that one was called, but so Taiwan 1337. I've done a video. I have a long form video on that particular reaction. It uses cerium and iron ions, and in concert, those ions will produce. I think the name of the video is like RGB liquid. The issue with those types of reactions is they deal with what are called oscillating chemical reactions, and I just got to be honest with you. Those things are not easy to describe. What's going on in an oscillating chemical reaction, you know, in order to help people really understand what's going on with those, it's helpful if you know differential equations. Let's just put it that way. Hey, thanks there, Taiwan. I appreciate that. Look at that. Come on, man. I mean, there are some things about oscillating chemical reactions that can be simply explained. But if you want to understand it all the way down to the guts, it's not easy. Need a little bit of calculus. Look at there, folks. We have definitely got some rainbow action going on. It's beautiful. having a good time here, doing some science experiments. Let's see what's going on with this one over here, shall we? This one's got less material, so it's easier to change the colors more quickly. In goes a drop of base. Boom, right to purple. Oh, maybe not. Maybe it's a little more blue. So long, Deadpool. Love you too. There's another drop. Yeah, hey, master. Here we go. I'm going to add a drop of acid over here on the right. Oh, better. Oh, I'm going to add another one. There's another drop. And we've neutralized it. Add another drop, and we've acidified it. Oh, okay, Taiwan. So basically, you need a nonlinear system then, okay? In order for an oscillating chemical reaction to occur, you're going to need a system of differential equations that describe the reaction. And then that system is going to need to be nonlinear. It also needs what we call an autocatalytic step. So what you need is one chemical species in the reaction. The presence of that species helps to generate more of itself. That helps to make reactions oscillate. The other thing that you're going to need is a feedback step in the system of differential equations that describe the chemical oscillator. When people first discovered oscillating chemical reactions, most of the chemistry field didn't believe it because they thought that such reactions would violate the second law of thermodynamics, which, in a sense, what you would have is a system at equilibrium that here in physics, you got a kid on a swing, right? So I got a kid on a swing that's swinging back and forth like this, and it swings through the equilibrium position, which is the swing is up and down like this. So in physics, or a mechanical system, I should say, this can happen. You can oscillate back and forth about the equilibrium position. And in chemistry, you can't do that. In chemistry, in a sense, chemical swings, so to speak, would just go boop and stop. And, that's because chemical systems are made of a bunch of molecules, and once those molecules hit equilibrium, you've got a whole collection of those molecules that have reached equilibrium and not going to move away from it. What they didn't realize is what you can get in oscillating chemical reactions is you get chemical intermediates. What this means is it's not the reactants, it's not the products, it's stuff that forms in the middle of the reaction. And while the reactants and products cannot oscillate, the chemical intermediates can. And once people realized that, they realized that oscillating reactions were indeed possible. And they also learned that some of the chemical oscillators were chaotic in nature. And in fact, all of them are chaotic in nature. It's just that, sometimes in a chaotic system, you're going to have regions where you have, periodic oscillations. So I hope that helps, Taiwan. I mean, that's the best I can do on a live where I'm not, writing differential equations on a screen or anything. What's the name of that one reaction that makes Dippin' Dots? Is that what you're asking about? Dippin' Dots, all you need to do is take ice cream mixture and drip them into liquid nitrogen, if that's what you're asking, but I'm not sure that's what you're asking. Hey, thanks, Taiwan. Thanks for, thanks for the question, and I appreciate you being patient with me with, trying to explain all that crap while I'm, we're just looking at a beauty of a chemical system. Oh, sorry I missed on that there, Master. I'm going to see if I'm going to turn this light off, see if we get a little, I kind of like that. I kind of like the way that looks without that circle light on. It's kind of interesting there. Pretty, looking pretty. All right, let's see if we can catch the rainbow here. It's like an orange right now. There we go. Now we've got to red. All right, here we go. Adding the base. Adding the base. It looks like a tardigrade. I guess it did there for a bit. Here we go. I'm going to add 4 drops. 1, 2, 3, 4. Let's see if we catch the rainbow, folks. Let's see if we catch the rainbow. I think we're gonna. We're losing the violet, so let me get a few more drops of violet in there. There we go. Come on, man. We want the rainbow. There it is. We got all the colors at once. It's just so pretty. Welcome to the rainbow, baby. Welcome to the rainbow. The wisps of violet from the base are just absolutely gorgeous. Very pretty. Very pretty. All right, see if we can set her up again. I'm going to try to turn this speed down just a bit more. Oh, I turned it all the way off. Just barely get her going. Come on now. Come on. Come on. All right, here we go. Some acid in there. Get her nice and red. Is this milk with food coloring and with dish soap as they expand one? No, that's not what I'm doing here. All I'm doing here is taking water, and there's an acid base indicator in the water that displays different colors at different pH values. So here are your different colors you're going to see at different pH values. This is red, which tells me it's pH 3, which is quite acidic. All right? And then what I do is I add base to the mixture, and that's going to neutralize the... I love the BZ reaction too there, Master. So I'm going to add some base to this, which is going to change the pH, and that's going to change the color. Well, sorry, there's acid I added. That's why the colors weren't changing. Here we go. Now I'm going to add some base. And if we're lucky, we see the rainbow, which I think we do. There it is. Oh, Taiwan showed the rainbow to their 3-year-old daughter, and she was impressed and said, wow, again. I'll try. I will try. Man, I love kids. I love doing experiments for kids. It just makes my day. Oh, I see. I'm sorry. I'm so sorry, Billy. So I've done a video on the expanding dots, and I've done it in glue. There's something kind of interesting that happens in glue with food coloring, and you add a little detergent to it. You can check out my shorts. It's one of my more popular shorts. I think it's got like 4 million views. So if you go to my shorts and look for the popular ones, you should be able to find it easy. Come on, man. We got to get the rainbow for Taiwan's kid. Come on, man. There it is. There it is. Violet-colored lasers are indeed pretty. Got to get that rainbow going. Come on, man. Let's get a rainbow going. There we go. The chemical rainbow. It doesn't last long, though, does it? Sometimes, let's try this. Sometimes I can get it to last if we do this. I'm going to get it nice and red. We're going to turn this off. And then I'm going to add drops of base. And we're just going to watch what happens. 1, 2, 3, 4, 5. Let's see what happens here. Maybe it's spinning too much. A little flash of rainbow. A little green and green on the bottom, red on the top. All right, turn that off. Yeah, the BZ reaction is awesome. All right, while I'm waiting for this one to stop spinning. Oh, here we go. Boop. And the other direction. Boop, boop. It's kind of neat. All right, hopefully this one has stopped spinning for a bit. There we go. That's what I need. I need it to drop really quickly. All right, let's see what happens over there. While that one's developing, we're going to focus on this reaction over here. I'm going to pour in just a little bit more of this water in this one. Just a bit. So we can get it over here on the top. top it off. There we go. Okay. Little base. Little acid. Oh, that's nice. A little flash like that. We got it to green. That's neutralized. Add another drop of acid. And just to show you what we got going on over here on the right, excuse me, the left. It's trying to figure out what it wants to do over here. There we go. Another drop. That drop of base, see what happens. Nice. Nice. And we got a static rainbow over here. We got a static rainbow. I'm gonna add another drop, see if we can't get that base color on the bottom to develop a little better. See the base sinking down. Yeah, we got a pH gradient building over here on the left, folks. We'll see how that develops over time. Let's go back to this dynamic system. We'll check this out every once in a while. I'm going to turn this speed down just a bit here. We'll add a drop of acid, 2 drops. Pretty. Got a little rainbow going. 3 more drops of acid. Look at folks. Look at that over there. Isn't that pretty? And I'm going to add another drop of, see if we add another drop of base here. It should drop all the way to the bottom. Yeah, what's cool about this over here, we have a pH gradient that has developed. What I mean by that is at the top we have, you know, a red color, which is pH 3. And then the pH changes, you know, incrementally. So we go from, you know, pH 3, which is red, to like an orange color, which is like pH 4 or 5. It just, you know, it just follows this colors right here and the various pH values. And right here in the middle, well, it's a little closer to the bottom. You can see that green region. That's where the pH is neutral. Really nice. Can I make a pH of 1? Yes, I can, AE Master. The deal is we're not going to be able to see the effect of that because my indicator system is red at pH 3, at pH 2, and at pH 1. So it doesn't differentiate between pH 3 and pH 1. All right, let's add I agree, AE Master. I think it's very beautiful. I'm going to leave that the way it is. Add a little drop of base. Do another little drop of base. Yeah, it's looking nice. Definitely looking nice. Look at that. Oh, it's so pretty. Man, is that pretty. Very gorgeous pH gradient going on over there on this side. I'm going to have to get a picture of that for sure after the live is over. Which is going to happen soon, folks. I'm running out of gas. I am definitely running out of gas. So at the end of the live, what I do is I flip the camera around. You're going to see my ugly mug. I'll talk to y'all. Little face reveal if you're into that kind of thing. And then we're going to call it a day. So, you know, for those of you who are here, I appreciate you hanging out. Does the internet go at the speed of light? I do not believe so. I agree there, Tare. I definitely agree. All right, let's get it going here. Oh. Flip the camera around, say hi to everybody. Check out that for a bit. See how y'all are doing. You get that here, flip her around. Hey everybody, how's it going? How are we doing today? Thanks for joining the live. We're all done with experiments. I'm just gonna sit and chat for a bit, and then I'm gonna probably go for a walk. I'm tired of staring at a screen. Thank you there, Master. I appreciate that. No Walter White today. Hey, Taiwan, thank you. Come on, man. Look at that. Taiwan sent me some money. That's not necessary, but I really do appreciate it. Thank you. I appreciate that a lot. What else we got going on here? Taiwan 1337. Very nice. Very, very much appreciated. You know, and that little bit helps. You know, it does cost me a little bit to buy, to buy all my materials. So, when people donate like that, it's helpful. So thank you. Thank you there, T Boogie. Come on, man. Tommy Technetium right here. Tommy Technetium. I know right where it is on my shirt. I don't think so, AE Master. I don't think Wi-Fi travels at the speed of light. Thank you there, Tara, the Protogen. Appreciate that. Give that a like, too. There, this is kind of cool. Look at the result of that experiment we got today. Can't wait to check that out later on. Very beautiful. I need to get I just got myself an idea. I need to get a time lapse of that forming. Thanks. You know what, AE? I feel happy when you comment. So it's mutually exclusive, or feelings mutual, I should say. Absolutely. You guys have no idea. You all have no idea how much I appreciate the comments. Is that right? Wi-Fi can travel at the speed of light? So, okay, when I hear this, I'm thinking the Wi-Fi that sends information to my computer. So I'm thinking as the information gets processed by my computer, that doesn't travel at the speed of light. You just stumbled across this. Somebody, Ace Chem 101, Organic 102. Hey, thanks there, Doc. Yep. Here, let's do this for Doc. Doc, we were just doing some science experiments. I don't know if you saw this stuff. I'm gonna add a little bit of acid to this flask over here on the right. And we can watch our color changes. It's just a pH indicator is all it is over there. That's what we're doing. But I just kind of think it's kind of beautiful. And it's kind of fun to, observe some color changes, talk about the science behind it, and try to get stuff looking like this as well. What the heck is that doing? That's kind of stuff we do here. And then at the end, I flip the camera around, talk to folks, and then I call it a day. Signals travel at the speed of light. Yes. However, assembling and disassembling processes slow it down considerably. Thanks there, Doc Dumont. That was my, 5G, right? 5G. What is that? And that go like at gigahertz frequencies. That's running at the speed of light. I know the G doesn't stand for gigahertz. What is it, like generation or something like that? But if I remember correctly, it's a few gigahertz. The wave frequencies. Nice. Loving the water chemistry test days. Fresh and saltwater fish. So, Doc, did you do some fishing? Is that what you're talking about, or just your own fish, like in a pond or in an aquarium or something? I think I'm gonna. You know what I'm gonna do? I'm gonna get some video of mixing that up, and then run it in reverse. That'll be fun. You could simplify it. Signals travel at the speed of light. Data travels slower. There you go, Doc. That's a great way to think about it. Thank you there, Peanut. Thank you much. All right, folks. I'm getting out of here. I've been staring at this screen too long. I gotta go walk my dog, get some exercise, stretch the body a little bit. I'm getting old, so if I sit too long, everything starts to creak. So thanks for hanging out with me and seeing the beauty. Thanks there, Doc. Thanks for letting me know about that. Very cool hobby for sure. Yeah, thanks for hanging out, folks. I appreciate it. I appreciate the comments. Appreciate the folks who send a little bit of money to support these lives. And hey, thanks. Thank you, Doc. for the subscription. I greatly appreciate it. I hope you enjoy the kinds of things that you see on the channel. And that's okay too. This channel's not for everybody. So thanks for hanging out. We're going to see you around. I usually do these lives on the weekend, probably Friday, Saturday, Sunday, one of those 3 days usually. You too, AE Master. Thanks for hanging